Hello, can you hear me? Can you hear me, Hardik? Hello, can you hear me? Hello, can you hear me? Hello, hello, can you hear me, all of you?
Yes, sir.
Yeah. So how was your chemistry practical today?
It was okay.
Okay. So let's start with some of the doubts Hardik has sent. Okay. And if you also have some doubts, Sarah, you can also send. Okay. For any topic you want to study, okay, because your exam is on 19th. Okay. So you cannot hear Hardik. Try to rejoin. Okay, maybe some problem. Hello. Yeah.
Oh yeah,
Can
I
you?
can hear you now. Yeah. Yeah. Can you hear me?
Yeah, yeah, I can. Yeah. Okay. So let's start with some of the doubts. Okay. Can you see this screen? Paint screen.
Yes, I can see it.
So his doubt is this. Okay. Another battery Q of EMF 1.2 volts and negligible internal resistance is now connected into the circuit 5.1 to produce the new circuit shown in the figure 5.2. Okay, so this is the circuit. So we have two cells 1.2 and 1.2, and we have two resistors X and Y 1.8 ohms and zero point 0.6 ohms. State whether the addition of the battery causes the current to decrease, increase, or remain the same in resistor X and then battery P. Okay. So what do you think?
So how will it remain the same?
Hmm. So we have two batteries, 1.2 volts and 1.2 volts, and what? They are in the parallel. They are in the parallel combination. Okay. Hmm.
Wait, what?
This battery 1.2 volts. Okay, this is 1.2 volts and 1.2
So,
volts.
but then when you add another battery in parallel, won't the voltages like add up?
See, but they are in the series. Okay, in series we are adding, we are putting them. Okay, so this P was already there, 1.2. We are again adding one more 1.2 volts. Okay, but it is not like this. Like in series we are adding. Okay, like in series we do like this. Okay, in this case it is 1.2 and 1.2. It makes a 1 point. It will get added up. 1.2 plus 1.2. Okay, it will be 2.4 volts. Okay, I think since they are in the series, they are in the parallel. Okay, so what will happen? They are asking about the current in the resistor X. Okay, so it will remain the same. Okay, it will not affect. Okay,
But wait, so if you add 1.2, then the current will divide. Like even if you add it, it will divide and then cancel the current in 1.2 volts with P. If you add Q, then will it cancel the current in P or something?
no, because they are in the same direction. This is also going from positive to the negative terminal. Okay, and this is also going from positive to the negative terminal. Okay,
Oh, so
because
they
of that.
cancel out each other, like the current?
No, they will not cancel out each other. Okay.
No, in battery P. I get it. In resistor X,
Hmm.
the current will remain the same because
Yeah,
yeah, I get that. But then in
remain
battery
the
P,
same.
if you look at them,
And then they're asking, uh, state whether addition of battery Q causes current to decrease, increase, or remain same in resistor X. So it will remain the same, and battery P. Okay. In the battery P, what will happen?
in the battery P, will it become zero because 1.2 voltage passing through 1.2 voltage? Will can won't it get cancelled out? Like, it will become zero, or will it remain? Why won't it remain the same?
Just wait, let me think. Okay. So current is going like this. They have a negligible internal resistance. Okay. Was P having some internal resistance? Check. Was P having some internal resistance?
What?
Was P having some internal resistance? Battery P.
No, there is no resistance to this. It was like it was actually just this P circuit, single circuit, and then someone just added Q to it in parallel.
So P
There
was
was no
having some
internal resistance.
no internal resistance.
Yeah, there was nothing.
Ah,
Negligible internal resistance.
mhm. Okay. So after this, what is happening? Okay. The answer is it will decrease, है ना? In battery P.
So will the voltage from battery Q flow into the battery P or something? And then 1.2 volts minus 1.2 volts becomes 0.
No, no,
And that's
that,
how it decreases.
no, in that case, no, no, that will not happen. Then no current will be there. Okay, voltage it doesn't flow. It is the current that is flowing. Okay,
Yes, the current which
it is the
flows.
current that is flowing.
Yes.
See. So see what I think na, that after from here, since it is not having any internal resistance, okay, so it is not having any internal resistance. So current follows the least resistance path. Okay, current follows the least resistance path. Okay, so what I think that then here the current will get divided. Okay, some will go to here and some will go to here. Okay, okay. Therefore, it is
Wait, then if current gets divided, how will the resistance increase? Like not remain the same in resistor X?
I think it will remain same. What is in the answer for the battery P?
The answer is the same. It's actually decreases. Resistor X remains the same and battery P decreases the current.
Okay. Okay, I will check it and I will get back to you. Okay, I will have to check this. Okay, why it is happening like this. Okay. So let us, anybody else is also having any doubts, we can send on in the group. Or if you have any topics which you want to study, okay, maybe we can have one more class. Okay, tomorrow we can take. Okay. So don't worry. Let us see some more doubts which Hardik has sent. So this is another doubt. This is the question. How many people are there? Only 3.
The rest don't have any
Yes.
doubts, I guess.
Sarah, she left the meeting. Okay. Okay. So this is the question. Okay. And I think there's some figure also related with this. This is figure related with this. Okay. So let us see. A ball of mass 0.2 or 0.42 kg is dropped from top of a building. The ball falls from rest through vertical distance of 78 meter to the ground. Okay. A resistance is significant so that the ball reaches the constant terminal velocity before hitting the ground. Okay. The terminal velocity is reached. The ball hits the ground with a speed of 23 meters per second. So this is the terminal velocity given to you. Okay. So
So wait, I think I forgot to wait, I'll just ask the doubt. Just a second.
so this is what the doubt, no, your doubt. The ball in B is dot at t equal to 0
Oh yeah, right,
and
right.
hits the ground at t equal to capital T. The acceleration of free fall is g. On 3.1, sketch a line to show the variation of the acceleration A of the ball with time t from t equal to 0 to t equal to capital T. Okay, so you have drawn a straight line and I
Yeah,
think,
how will it be a curved graph?
so this will be some, why will it be a curved graph? This is your question. Okay, so see, this is the ball. This is the ball that is falling. Okay. So what happens? What are the forces that are acting? Acting, that is the weight. So it remains the same. Weight is equal to mg throughout the whole journey. Okay. Throughout the whole journey as the ball is falling down. Okay, from the top of the 78 meter. This is the ground here. Okay. This is the ground here. Okay. And what is happening here? So there is that in that air resistance is significant. Okay. So there is some drag force is also acting. Okay, FD, drag force. Okay, and this drag force is kind of a, it is proportional some function of say v square something. Okay, so what is happening? This
So
mg,
how will it be v square?
it is some function of some v, some velocity. Okay, the drag force.
But then why square? If it's square, then yeah, of course it will be curved. But then how did you get square there?
Which you see some of the questions on drag, so they give some format for the drag force. Okay, so it is some function of v or v square something. You can see some questions. Okay.
So is it like related to like the kinetic
Related to the
energy?
velocity. So as the velocity will increase, so does
Yeah,
the
as
drag
the
force.
velocity increases, the drag force will increase and resultant force will decrease.
So what is
So
happening? Throughout the journey, the weight remains the same, and as it is coming down, there is an acceleration. So there is some net force that is acting. That is F net. Okay, and this F net is equal to what? That is equal to this mg
mg minus ma
minus the drag force. Okay,
minus the drag force.
minus the drag force. But
So
the
ma.
drag force is increasing. What is happening? What is happening? This F net I can replace by m mass of the ball into a net. Okay, okay, and that is equal to this net force, mg minus the drag force, mg minus the drag force. So what is happening? The net, as I can write down, a net will be equal to what? A net will be equal to mg minus drag force, mg minus drag force divided by the mass. Okay, so what will happen? This will be a net will be equal, this mm gets cancelled, and this will be g minus fd upon m. So g is constant, mass is also constant, and since this fd is increasing because velocity is increasing, so this g minus something, okay, which is increasing, what will happen? This will decrease the a net. Okay, so a net will no more remain constant. This will also keep on decreasing with the time. Okay, therefore the graph will definitely not be a straight line. Okay, okay.
Wait, definitely how? Wait, because
Uh,
now so so is it because
so
is it
therefore
wait,
it
so
is some
G
kind of a
will
curve.
wait, G will decrease and simultaneously at the same time the FD will increase. So that's why it's squared. Is that the case?
So some kind of a curved graph, maybe something like this it will be. Okay, some curved graph like this will be. Okay.
Wait, why will it curve like that? Should
Have they given some
oh
curve? Have they given the nature of
wait,
the curve?
I'll check the marks in just a second.
Nature of the curve have they given? I think this will be curved like this. Okay.
So why will it be curves like that?
Uh, See, because we have
No,
to.
because
Hmm.
oh yeah, because G will the rate at which G increases will decrease. No, it will increase at
Yeah.
the wait.
Okay. Yeah. So if I find out the slope somewhere here, this is Some value is there, and here the slope will be kind of a straight line. Okay.
But then still, I still kind of don't get like how. No, because the equation you said like the proportional one, proportional to v square.
Hmm.
How did you get v square there?
You search some of the questions. Okay, how does the force looks like? Okay, the drag force. Okay, so as such, we don't have any drag force. Okay, is there some formula for drag force? You can check in a formula for air drag. Air drag. See, there is some function of some velocity, something. Okay, square of velocity, something. See here, something.
Oh,
Fd is equal to
so
half.
how am I supposed to know this? This was never
That is
told to
not in
me.
the syllabus. Okay, so what some
Yeah.
FD is equal to half rho v square, some complicated thing. Okay.
Oh, so I'm supposed to use the thing you used, like FA, sorry, FD equals mg minus F
Yeah.
net.
Yeah.
I have to use that.
Yeah. Okay. So this rate
So
of
is this like the case with everything? Like as except well, because so if there was no air, suppose there was no air resistance, then acceleration will be like a straight line, right?
yeah, because acceleration will be now the acceleration due to gravity. So it will be a parallel line like this, straight line like this, like this.
All right.
Okay.
All right. That's it. Understood.
Lasha, did you get that? Are you hearing?
So the force always in sorry.
Yeah.
No, just say right here.
Okay.
Go ahead, Hardik.
Yeah. So the force always increases proportionally.
Hmm.
I mean exponentially. Sorry.
Now next question. Were you able to complete the chemistry practical? Both the questions? 3 questions are there. No?
Yes, I was
Yeah.
able to.
To complete it.
Very good. How was the bio exam?
So it was super lengthy.
Yeah,
Very
your
lengthy.
ma'am was telling it was lengthy. Were you able to complete, both of you? Or did you miss something?
It was quite
Same.
no, sir. There was a lot of writing, so it was tougher than like the previous papers I had solved
Hmm.
because writing takes a lot of time. There were no questions like where you just write one word, you just tick, and you get one mark for that. There were no such questions, so you had to write long answers in most of the questions.
Okay. Okay, so this is the question. A stationary wave is formed on a different string.
So wait, what's the question?
This is the question you can see on the screen.
Yeah.
A stationary wave is formed on a different string that is stretched between two fixed points x and y. Figure 4.2 shows position of the string when each point is at its maximum displacement. Okay. So now, what is the doubt? Say the phase difference between points y and z. Okay. Phase difference between points y and z they are asking. Okay.
Yeah, how is it 180? That does not make any sense.
Okay. So see here. So how much is that much? See here. So this is the first point here. Okay. First point is here. We draw using some another color. This is the first point W. Okay, the second point, Z, okay. Yeah. Hmm. We will again renew this meeting, okay, after 10 minutes. So see here.
Wait,
Yeah.
what? This is a free meeting. All right, yeah, sure.
So see here, from here to here, how much is the difference? That is lambda by,
Wait, I'm confused. What do you need to do here?
you have to find out the phase difference. Phase difference we have to find out. Okay. So this is an anti-node and this is a node. So distance between anti-node and node is lambda by 4. है ना? Lambda by 4 and this is even half of that. है ना? This is lambda by 8 I think. Okay. Even half of that. Okay. So this is lambda by 8. Lambda by 8. The total path difference between them is path difference is equal to lambda by 4 plus lambda by 8. Okay. So 8 if I take, okay. So 8 if I take the LCM, it will be 2 lambda plus lambda, that is 3 lambda. Path difference is 3 lambda by 8. Okay.
Now multiply that by 360 and you will get 135, which is wrong.
So path difference will be 2 pi by lambda into path difference. Right? That is 3 lambda by 8. Lambda lambda cancels, this is 1. So 3 by 4 pi. And pi is 180 degrees. So how much? 90. 45. 45 into 3. 45.
135.
It's coming 135 degrees. And answer says how much? 180 degrees.
Even I got 135.
W and Z on the string. Phase difference between W and Z on the string.
So I'll just try looking for the working on the internet.
Okay.
You can try figuring it out.
Lambda by 4 plus lambda by 8. I don't know, we'll have to check it, okay? Let's do some other question. I think Yeah, this question was also your doubt. This
So
question.
there was another case. So you know this thing. There was another job.
Hmm.
Yeah, there was another case in the one where I got 135, but the actual answer was 180. Well, I'll send you that too.
See this question, okay. A stationary sound wave in air has amplitude A. In an experiment, a detector is used to detect A square of the amplitude. Variation of A square with distance x along the wave is shown. Okay. So A square on the y-axis and x on the x-axis. Okay, so you can see that the figure is above. Okay, because square of the
So
amplitude.
what kind of graph is this? Usually we see time on the x-axis and the displacement on the y-axis. Yeah.
So this is amplitude versus the distance graph. Okay, the wave is moving, going ahead. Okay, and its amplitude is increasing and decreasing like that. Okay, so it is the square of the amplitude versus the distance graph given to you. Okay. Hmm. So state the phase difference between vibrations of an air particle at x equal to 25 and x equal to 50. Okay, so x equal to 25, so x equal to 25 here, and x equal to 50 is here. Okay. X equal to 50 is here. Hmm. Hmm. Okay, see here. Uh, so this is an A square plotted against the X. Okay, so the original wave will be what? Original wave will look something like this. Okay, original wave will be something like this. I'm drawing. Okay, this is the.
Oh wait, I get it. Because yeah, oh, it will go up and then down,
Uh,
and that's how you get 180.
okay,
Am I right?
so it is like this, and original wave will look something like this. Okay, amplitude will be positive sometimes, sometimes negative. It will be okay. All right. But here what we are doing, we are keeping the x as the same, but when we are taking the square of the amplitude. Okay.
So that's the
Don't we
time.
do?
They should. Won't that be time on the x-axis?
Just see here. Okay. So if I do the square of it, okay, what will happen? The positive will remain the positive, but this negative will also become positive. Okay. And this negative graph will also become the positive one. Okay. And
Oh right, because it's a square.
something like this. Okay. So this will get discarded. Okay. This graph will get discarded.
All right, and understood.
This graph will get discarded. Again, we will join in 5 minutes. Okay, don't go anywhere.
So it's fine. You can move on to the next question. I understood this now.
The meeting will end in less than 1 minute. Okay. Right.
Yeah, I know Elisha is not going to join the next time.
Okay.